unboxing. The 100 amp hour Sungold power battery. Not a whole lot of sun right now. So this battery's not going to charge till tomorrow probably, but I guess we'll see. Alright, so here's a packet of wires. This is a comms port so that your batteries can talk. Get this open. And the screws. So they do a pretty good job. Let me see if I can get this up here. They do a pretty good job of packing the battery, so it's pretty much guaranteed to be in good condition when you get it. And FedEx can't screw it up that much. Let me open up the plastic. So this is the SG48100P. The 48 stands for, oh man, this is upside down apparently. The 48 stands for 48 volts, and 100P stands for 100 amps. So one thing, oh, sorry about that. One thing that you want to notice is that this is a 125 amp breaker, but the battery's not rated at that. That's for a completely open circuit where it'll trip if you do that, if you short it out. And then also on this chint breaker, you want to notice that green is off, red is on. So let's turn that off. One thing, this sucker is heavy. So when we're installing these in our systems, in our customers' places, it's pretty tough work. Not even gonna lie, pretty serious, because these batteries are heavy. Off of here. Great. Sorry about the camera issues today. I am one-handed with the GoPro mount. Okay. Whew. So there we go. All right, and let me get these things in parallel. I'll show you how that goes. All right. So for parallel mode, all right, let's do the dip switch settings. Page 17. All right. So for the dip switch settings, I can't get page 17. There we go. So, if you have the 0 pack, we'll call that the first one. We have 0, 0, 0, 0. Off, 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 off. And that's what we got. Okay, pack number 1. On, off, off, off. Alright, so I'll do that. So, on, off, 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 off. Alright. And here we go. Alright, so we have 2 packs. Slave pack 0, slave pack 1. Okay? That's the dip switch settings. Here's an image. If you want to capture that, hit pause. That's so you can set your batteries up and give them, tell the BMS that you have a battery that is, you know, 0 or 1 or 2 or 3 or 4 or 8, whatever number you want to assign them. And so you want to make sure they're all different, because this has 15 numbers, and so you want to make sure that you give each one of your batteries a different number, a different address code. All right, now what we want to do is set these in parallel, because we need the same voltage. We just want more amp hours. And if you set it, if you set them in series, then they'll be back to back, so it's like a fire hose. So this, by convention, this is the positive side, but electrons actually come out of here, so are released from this side, and so they travel through the circuit and come back around to the negative side. That is not correct. The electrons come out of here, which means that if it comes out of here, then what's left on this side is positively charged electrodes. An electrode that is positively charged, because the electrons are leaving from here. That's why it's always important to connect up the ground first, the negative side to any circuit, and then you go ahead and attach the positive end, because the electrons are shooting off of here, and so you'll get a spark. But then if you connect up this ground first, and then you connect up the positive end, you will actually not get a spark, because the electrons are not being forced out of the battery. They're being absorbed on that side in the circuit. So that's something important to remember. It's just a rule of thumb. You connect up your ground first, or your negative electrode first. All right. So let's see if I can get to this page. You're watching all this in real time here. Get to the page where we connect these in parallel and see what it says, how they talk. RS232, is that what they gave me? Nope, they gave me a 485. Okay. Communication mode can be up to according to the customer requirements. So parallel function. All right, number 23. Parallel function supports up to 16 batteries in parallel. Battery system performance parameters. 16 in parallel. That's a lot of. That's 1600 amps. That's a whole lot. Definition of terms. I want to see it in parallel function, so let's see if we can find that. Panel schematic. More settings. See, I understand how to set it in parallel. So, I mean, I'll just connect both negatives together and both positives together, and then just plug them into the battery. But the difficulty comes with this communications thing, because I don't know anything about it. Parallel communication port. Here is the diagram. So the CAN, the CAN, and the RS485 interface is one thing. CAN and RS485 interface is one thing. And then you have a parallel communication port, which is here. I am wondering if I need just one going from one to the other. Let's see here. Parallel communication. Using an 8P8C vertical RJ45 socket. I'm guessing that is that. 1 and 2. Let's see here. So RJ45 pin 1 will be on RS485B. All right, 1 is on RS485B. And 2 will be on RS485A. Two will be on RS485A. So let me, before I plug it in to A, let me just make sure. With dual RS485 interface, you can view the information of the pack. The default baud rate is 9600 bps. To communicate with the monitoring device through RS485, the monitoring device is used as the host to pull the data according to the address and the address setting range, 2 to 15. So it looks like I don't have to use this, which is a for me, because I'm not hooking up my laptop to it to communicate to anything. So yeah, no. Bye bye. All right. Oh, here's the profile. So in minutes, charge time in minutes, if you have current, the current is held constant at 45. Oh, no, sorry. Current is held constant at 20 amps. Then your voltage, here's the profile of the charge voltage. And then after 300 minutes, you'll get a big spike, and then you'll get the cutoff. You hit the cutoff at 54 volts. That is cool. That's important right there. Take a look at that. So you get constant amperage, meaning those electrons are being fed in, and there's a flow of electrons coming into the battery. And then after 150 minutes, you should be at 50 point something volts. And then the second half of that, after 300 minutes, you go up just a tiny bit to 54 volts. So that's important to know, because you're not necessarily at 50% charge, 100% charge, when you're not at 50% charge when you're at 150 minutes. You've done the bulk charging, but to get a full charge, you got to go twice 150 minutes. All right. Hope I said that right. LED descriptions, alarm, it flashes when it's at low voltage, and it flashes when it's at over voltage. 3 seconds, 3 times for 25 seconds or something like that. Yeah. Wake the system. The output of the charger must be greater than 48 volts to wake the system up. Okay, so it looks like I don't actually have to use this communications port. and I really don't want to, so that's what I'm gonna do. Alright, so let's get started. I still have some sun left, so we might get like a tiny bit of charge. This is the negative side, so let me cut this off. Let's see what we're doing here. We're getting 4 amps, so we're missing out. We're at 53.87. We're really almost full. It's flashing. It's still flashing, which means it's not fully charged, but I want to hook this up, so let me disconnect this. Alright, and we'll shut this off. And this is still live. Remember, like, I didn't disconnect the solar system. I want to make sure that right, so I shut off the battery. I want to make sure that let me check to make sure that there's no amperage. Yep, 0 amps. Yeah, so I'm going to disconnect here. This is still charging, so if I was to disconnect here and here at the same time, I could run into some issues if I touch the wrong thing. So I'm gonna don't try this at home. I am a professional. Like, when I say professional, what I mean is I do this for myself, and I profess to be an expert at this, and so that's why I do this for other people. I help people out. So I'm going to take off the negative, and let's see what we're going to do here. We are going to get this. We're going to have to add another switch on the other battery, but we'll do that later. And so I'll add this here. Looks like I'm going to need another, because these are not going to be even. I want it to be even. See, the length of my positive cable is longer than my negative cable, so I definitely want to fix that, but it's not a big deal, but I do want to fix that. You know what? Now that I think about it, I should run it to the bottom post. Yeah, the bottom post here is a little better to run it to, because the bottom post is the one. Bottom post is the one that can reach, well, the top post can reach to the top battery, so I'm going to put this on the bottom post. I like to be safe and work on my solar systems in the evenings or in the early in the morning when there's not too much sun and not too much power coming out of them. Because DC is pretty dangerous if you have high voltage, which this is. And so, yeah, you don't really want to start messing with this stuff when in like full sun and all that. A lot of amperage, a lot of amps. I'm gonna need to crimp an end on here. Maybe I'll use this one. Guys, it doesn't have to be perfect, okay? It really doesn't. As long as your connections are solid, then you're good to go. And I'm going to use this. Reuse the connector. If I can get this off, that's the whole thing. All of this hinges on whether I can get this out of here. Maybe I need to take a screw. If I can find one of those. Screw. Who has screws? Not me. Not the electrical solar panel guy. Really? Come on. Okay. There we go. Oops. Okay. Here's my cable. You know what? I'm going to need a positive and a negative. I should have kept this one on there. It's all good. I have others. It is all good. No worries. So you set this inside here, like so. Oh, gotta squeeze it down. Oh, sorry guys. There we go. Put this on the back side. Boom. On the back side and boom. It's on there good. Okay, back up there. You know what? I could have just used the ones. Now that I think about it, I swear, like sometimes I already worked today, by the way, so all this is happening after I worked. So the truth is, you're gonna have a terminal end with each side, and you just want the terminal, the node that attaches to the batteries to be opposite. So I want this to attach to the battery. It's already attached to the battery. This would be a terminal end where it just stops, it ends right here. And then this side, I want this bottom corner here, I want this to attach to the battery, and it already is. So all I need to do is make a jumper right there. And instead of using the slightly different gauge, this is the same but slightly different because it's copper. It's not, it's just a little different. I will take this off, not use this. I'll use the factory wires that they gave me, and yeah, that's what we'll do. Man, jeez. So yeah, like I said, I'm a professional. But professionals still make mistakes, so here we go. I'm gonna use the cable that came with it. I'm not gonna do anything special. Nothing special here. No special anything. But I certainly did waste a few minutes making a jumper cable, a bus bar. So that was a waste. But not really a waste, because now you've learned a lesson, right? You have learned that all you're going to do is bring one end to of each battery to the inverter. That's what you learned. Okay. I still make mistakes. Alright, so that's it. Bring this over here. Cover that up for safety. Cover this up for safety. Get in there. And then we'll jump over here. And then we'll have 200 amps once I reset this battery. Do the reset procedure. Because when they ship it, it's really discharged. Heavily discharged, so it doesn't have any voltage. It needs to get charged up in order to come on. At least 12 volts. I heard you. You're telling me about how I'm using a flathead driver in Philips bolts. But I don't care. I'm just getting, it doesn't matter. Just getting it done. Okay? Leave me alone. Leave me alone. But that's cool. We're going back to red on this, so I appreciate that. Yeah, at the very least, I appreciate that. Last connection here. We should not, but let's see if we get a spark. We should not. But let's see. Let's see if we do. No. No spark. All right, we are all wired up in parallel. The video is much longer than it should have been, but don't worry. All right, so I'm going to reset this battery now. I'll show you. You just hold this for 5 seconds. Once I get something to poke in there. This for 5 seconds. And it is on. So now let's see. We can get this. Oh, looks like the voltage is not high enough. So let's see. Still off, so probably need to let me see if I can charge up this battery. So now we're operating on the bottom battery only, and it looks like it came on. Let's get you guys in here real close like. Okay. All right. I'll take a look at this. So, oh, they gave it to me with a little bit of charge. How sweet. Oh, they're so kind. So, we go to the menu. We're on analog information. Let's look at the analog information. Oh, we're getting 0.3 amps. Now, here's the kicker. Let's see what the voltage is when I flip the switch for the other battery. This is gonna be interesting. All right, let's flip the switch for the other battery. Same voltage, different battery. All right, let's see what this one says. Let's see where the amps are going. It says it's losing 10 amps and the bottom battery is gaining 10 amps. All right. These batteries are equalizing. That is so cool. That is so cool. Now let me explain this because let's keep this on. All right. Here's what's going on, right? So that one back there, I'm not sure if you guys can see that. Negative, it's losing current at 53 volts, and this is gaining current because they're equalizing. So here's what's happening. Battery number 1, almost, fully charged. It's fully charged now. Has a lot of juice in it. Think of it as juice. It has a lot of juice in it. And battery number 2 is empty. Well, not as full. It's like halfway. And so the juice from, we're talking about electrons here. The juice from battery number 1 is overflowing and running right into battery number 2 with the same, equal but opposite flows. That one says 3.6 and this one says 4.5. So I'm suspecting that the difference. These ants are all over my toes. Damn it. I know they love to eat me, especially in the evenings. But yeah, they're definitely biting me through my sock. Yikes. Let's take a look at my foot. The ants always go crazy. I don't know if I mentioned that to you guys. Can you see any? The ants go crazy when they get around this inverter in the evening. It's the weirdest thing. But they like to eat me alive. Anyway, back to the program. So yeah, batteries are equalizing, and that's a good thing. They're supposed to do that. That means we're all set. We're still at the correct voltage for the inverter. I guess I'll take a look at what the inverter says right now. AC is off. Input AC is off at normal. There's no load, and battery voltage is 52.8. So yeah, this is great. This is great. I'm satisfied, and let's see how long this lasts through the night. All right, that's all I got for you guys here. I'm gonna get out of here because the ants are bothering me, and I need to spray these suckers. All right, deuces.